Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello, my name is Leandro Facchinetti, and let's write some code together, shall we? Hang on, is there something weird with my green screen? Yeah, you can sort of see part of my room over here. What the heck? High production value today. So what we have on the menu today is to add two features to the Automixer that we have been working on. Oh, hang on, this is gonna bug me so much. I will just trim this so that you cannot see my room. There you go. That's slightly higher production value. So, two features. They are on the title of the stream. The first feature is the Automixer will assign different priorities to different tracks. So different microphones will have different priorities. And this is useful if you have something like a moderator. Hang on, it feels like I'm getting ahead of myself here. So what we are doing here is we are developing real-time audio effects for REAPER. And we are developing this library that helps you draw stuff on the screen to show what the effect is doing to your audio. We are using the JSFX language, so we are developing this library in JSFX. And in particular, the effect that we are developing now to use the library is a new version of something called an Automixer that is useful if you have multiple microphones in a room and you want to prevent the voice of a person being picked up from another microphone, or at least to mitigate the bleed that happens in that context. So think of a round table, an interview, a podcast, that kind of thing. The Automixer will assign the different microphones, different gains based on who's speaking. So the priority is something that you can say, okay, this microphone is the moderator. It has a higher priority. If there is crosstalk, if multiple people are speaking, the moderator will have higher gain allocated to that person. And the second feature that we want to try to implement today is the notion of strength. So the Automixer is going to assign different gains to different microphones to prevent bleed, as I just explained, and it will always attenuate. It will never boost the gain on the microphones. It will always attenuate. So people who are speaking will have very little attenuation on their microphones, and people who are not speaking, presumably that's bleed, then their gain will be attenuated. But in full effect, if you just load the Automixer and it's working at its fullest, it will assign a gain to all the different microphones that adds up to 1. So it is as if there is one microphone and people are sharing the microphone. But I can adjust the strength of the effect or the strength of the attenuation so that it does not necessarily add up to 1. The effect is more subtle. It is similar to a dry-wet knob in other plugins, I guess. Maybe we would even call it dry-wet. And Benjamin is here. Hello, it's great to see you. I hope you enjoyed this session. Let's get started. We have a previous version of the Automixer that implements both of these features. Let's take a look. So this is the existing version of the Automixer. We are developing Automixer 2.0, but if you're interested in this version, you can always go to the link in the description, go to my REAPER GitHub repository, install the repack repository, and you will get this effect. And here are the priorities. I only have sliders for 4 priorities visible, but there are these hidden parameters for all the other 32 tracks you could have with different priorities. And then you could say perhaps track 2 is the moderator. I will increase the priority of that person. So if both the moderator and someone else are speaking at the same time, at the same level, the moderator will be 4 times louder. That's the intent anyway. And we are going to be referring back to this implementation because I don't fully remember everything that goes into implementing this. We'll get to that. And then there's the strength. So at 1, it is at full strength, a single microphone being shared in the room. Then for higher numbers, that's actually an interesting thing. The effect is even more pronounced. So the bleed will be even more attenuated at the cost of perhaps artificial artifacts. It will feel artificial because the gain will be going up and down so much. And then you can also relax the Automixer and it will not attenuate as much. It won't get rid of as much bleed, but it will make the transitions between speakers somewhat more natural. All right, and by the way, just looking at this interface, we can see that the previous version of the Automixer has this feature here. Yeah, let's take a moment to actually see all the features from the previous Automixer and see what still makes sense to translate. And Tail is here. Hello, Tail. It's great to see you. So the previous version of the Automixer had these 3 modes of operation. In this mode of operation, it will add up all the tracks and produce a single signal, a signal track. So perhaps if the microphones are mono, this will produce a mono signal out. In multi-track output, it will attenuate all the tracks, but it will pass them through as different channels. And if you're interested in knowing how the channels are set up, you can just watch previous streams. This is a centralized version of the Automixer. We are doing a distributed version. There are other streams in which I explain all of this stuff. You can just go to the history of the channel. And then there is this third mode of operation that is bypassed. And that's because you cannot simply bypass the Automixer. If you tried, you would be outputting only one of the tracks because of the whole routing mechanism that is going on in this effect. It's quite complicated. That's why I don't want to explain it again. It would take like 5 minutes for me to explain this again. So anyway, you cannot bypass this plugin this way because of the weird routing situation that exists here. So instead I had to implement this bypass. And the cool thing about the new architecture, the so-called distributed architecture for automixing, the cool thing about this is that this is no longer necessary. The single track output doesn't even make sense because your DAW is now doing the actual mixing. The multi-track output is, I guess, the thing that we are doing now in the distributed version. And the bypass is just completely unnecessary. You can bypass the Automixer instances and they will just behave because we implemented a cool tracking mechanism last time in our previous coding session on Friday. The number of channels per track is no longer necessary because the Automixer is just picking up the number of channels on the given track. And what is even cooler, you can have tracks with different number of channels. You can have heterogeneous tracks, while in this version you could only have homogeneous tracks. Super advanced edge case. I don't think anyone will ever use tracks with different numbers of channels, but we support it. Then the reaction time we have already implemented. The strength is what we are implementing today. The priority we are implementing today. And look ahead, we'll probably implement tomorrow. Which is super interesting actually, because the look ahead has a bug in this version. I was silly and I declared one more sample than necessary for look ahead to work. So even if your look ahead is of 0 milliseconds, no look ahead at all, you still have one sample of latency. And of course, you cannot delay one sample. You have to delay a whole buffer. So silly me. So we'll fix this bug when we get to this tomorrow. And then there are features that have to do with video. And that is also super cool. We'll get to that sometime this week, I hope. Let's dive into priorities first, because they will be interesting. In this version of the plugin where everything was centralized, we would have all these sliders, and we would artificially limit the number of tracks to 32 to make all this work. And also because the routing mechanism in Reaper has a limit of 64 channels. So we were using channels as tracks. We couldn't go beyond 32 if we had any stereo action going on. And in our previous version, we didn't even admit mono tracks. See, it was kind of wasting resources because it was computing the RMS of mono signals by adding both sides and dividing by 2. Anyway, so the first thing is in this new version that we are developing, let's label this the old. In this new version, you load the plugin in all tracks that need to be automixed. So we don't need to have a bunch of sliders for the priorities. We can just have one slider, and each instance will have a different value for that slider. Now, we implemented this cute little trick before where you can change the RMS window length, which is a parameter that I think makes sense to be global. You would like the RMS to be the same in every track. If you switch the RMS in one track, that change reflects on other tracks, which is neat. But this other slider we are talking about, the priority, is a local setting. So let's have a slider that we'll call the priority. And I think I will stick to the same range and step as this one. Let's take a look. The priority goes from 0. You can assign a track 0 priority. That's essentially muting the track. Does that make sense? Perhaps not. And Bo is here. Hello, Bo. Great to see you. If you only can do plugin delay compensation in sample blocks, how do you fine-tune plugin delay compensation? Okay, so you can only declare plugin delay compensation. You are the plugin, okay? You are the plugin, and you introduce latency because of the way that you need to operate. So, for instance, you're doing look ahead, you will delay some samples. Then you are the plugin, you declare how much you are delaying the samples by. And I think you can do here on this on the init block. So you say plugin delay compensation bottom channel, something like this. I'm not pretty sure, but I think it's this. So this is, suppose that a track has 15 channels, and perhaps you would only be delaying channels 9 onwards. You could do that by saying the bottom track that is being delayed is track 9. I don't know. It really are channel. The channels that are being delayed are 9 onwards. Now this is silly. In the Automixer, and I guess in most effects, all the channels will be delayed by the same amount. But anyway, you have to declare this. So you have to say, for instance, this means delay tracks 0 and 1, because this number is inclusive and that number is not inclusive. So delay tracks 0 and 1. In most cases, you will just want to say, I want to delay all tracks. So perhaps you would do something like this. Anyway, then you say by how much you want to delay by. And I forget what the name of the variable is. But then you say something like, I want to delay by 200 samples. Now, this is you. You are the plugin. You declare this much latency because perhaps you have 200 samples of look ahead. But the host may not be able, I guess, in most cases, the host will not be able to delay by just 200 samples. Because remember, we may have this nice construct here of the sample section in JSFX, but we know that for real, the way that this is processed is with blocks of audio. And the block, of course, is set by the parameter that you configure REAPER with. So you are working with blocks of audio. So even if you declare a latency of 200 samples, the host still has to delay a whole block. That's what you see on the lower left here. You see a plugin declaring its latency and then the real amount of latency that was introduced by the plugin because of this situation I just explained. My plugin was incorrectly declaring 1 sample worth of latency, but REAPER is really delaying this by 256. And REAPER is super smart, so if you have other plugins that introduce latency on the same chain, it will bundle all the latencies together if you want. There is a setting to turn this off, but by default, it will bundle all the latencies together and you will get the lowest multiple of your buffer size. It's kind of nice. Anyway, let's not deal with that right now because we are not doing look ahead right now. We are doing priority. But I hope that that explained the question, that answered the question. If it didn't, then make sure to ask a follow-up question. All right. So we have a slider. That's not much. And we don't even like the range of the slider. It doesn't really make sense to assign a priority of 0. So that's essentially muting the track. So I will say that the minimum is 0.1 and you can go up to 10. Now, does this make sense? Perhaps not. Because you have a range of going to... No, yeah, I guess it makes sense. It is a weirdly behaving slider where there is a lot of material to the right, but very little material to the left. I don't know. I'm not sure I love the range on this slider. We'll get back to it at some point. But what is really important is that all the priorities for all the tracks need to be available for all the tracks. All other tracks need to see it. In the previous implementation, where we had a bunch of sliders in a single centralized plugin, that was a piece of cake. All the priorities were available as simple sliders. But now, we'll need to put this priority in the global namespace, the global chunk of memory that we are sharing with other instances of the plugin, and we'll need to do that because every plugin will need to know the priority of every other plugin in order to compute its own gain. Oh, okay. I'm glad. So we already have this notion going on here of a track. So we are organizing the global memory using this arrangement, using this data structure. Let's just add another field. We have the updated at, we have the RMS. Let's also have a priority. And now this data structure has 3 fields. And let's, when you change the slider, let's update ourselves in the global namespace. Yeah, we need to get something that looks like this. This is how we address into this weird situation that we have going on. So we are interested in this argument or this field, and the rest is already there. There you go. And then that. That will set things in the global memory, all right, but I'm not sure I love this variable name because I think it will clash with stuff that I would like to do down here. I guess I will rename this to be priority slider. I'm not sure I love the name, but anyway. At least it doesn't clash with anything. So there you go. Now we are writing this priority to the global namespace, but we are not reading and syncing and whatnot. So this that was necessary to sync the RMS parameter will not have anything like that. So what I want to do is test that the plugin is still working, even though I just added a couple lines of code, but I want to make sure that this modification, for instance, didn't break anything. Because it may be the case that I had some bug in the code and it just happened to work by accident, and now that I have another field in the data structure, it no longer works by accident, so I think it's nice to check this. And I will do the same setup I'm doing lately, where I have my own voice in one channel and sine wave in another channel. And the two automixers are already in action, actually. Let me put the sine wave in a range that is similar to my microphone. And then you can see that the sine wave is bouncing down to make space for my voice when I speak and bouncing back up. So the automixing is happening. Good. At some point, we'll need to do some listening tests, but not right now. So we are writing this priority. Now let's come here and modify the algorithm to take the priority into account. And the way that this works is, first, we compute the RMS of the current channel. We don't need to change that. Then we will compute the sum of all RMSs and I was going to say that we now need to collect the sum of all priorities as well. But hang on, the truth of the matter is that we may not need to know the priorities of every other channel. Here is a little trick. When we compute our own RMS and we put it in the global namespace like this, how about we just multiply by the priority? So if the priority is 1, we'll be not changing the RMS and it will continue to work as before. But if we multiply by 10, then it is as if the RMS of this guy is 10 times more than it actually is. So it will have 10 times the priority. And that simplifies a bunch of things. Hey, let's do that. And now I'm getting rid of the code I just wrote. I know. In fact, it's rare that I use git reverse, but I think that this may be the case, because I think that the changes I made were exactly the wrong ones. They are exactly in the wrong direction. Yeah, and I think that these are exactly the changes that I undid. So how can I just rebase, reset, commit, drop, reverse? Are you sure we want to revert? Yes, I never use this feature. Cool. So we are reversing back into the other state, and I copied the line that has this slider because that line we still want. Now we take the priority, and over here we multiply, and that's that. This will return the RMS, this will multiply by the priority, and I think that will do it. Let's try. Okay, so far the priorities on both tracks are exactly the same. And this is the kind of bouncing up and down in the region that we are occupying. Now let's increase the priority of my voice, and what I expect to see is this bouncing down even further, because when I speak, I am the moderator. My voice should be on top of the other person who is cross-talking. So let's see, I'm going to increase the priority, and there you go. It goes further down. But still, when I stop speaking, it comes back up. See, if I am silent, I can play with the priority left and right, and this doesn't change. It's still at the same level. Almost no gain reduction is taking place, actually. Awesome. This is exactly the behavior that I wanted. And we did it with a single line. Great. Now let's go to strength. And that one is interesting. Let's see how I implemented this in the old Automixer. First, I want to see how I implemented priority to see if I was as smart a couple of years ago. It seems like no, because the track's priorities are an array here. Yeah, it seems like I just multiplied the track's priorities at this point, but for whatever reason I stored it in an array. Doesn't really make sense to me, but it seems like I multiplied. Oh, I multiplied the aim gain. Oh, interesting. So I guess I will translate this to the new version just so you can see what I mean. Instead of multiplying here, I multiplied here, which is what I was going to implement in the first place. That's why I was storing everything in the global namespace, so that I could multiply the priority of the track here. I must have had a reason to do it this way, but I don't really remember what it was right now. Because in the end, it would be just a gain. And then I normalized the thing again. Yeah, I don't know. I don't know why I did it this way, but perhaps there was a reason. I don't know. Anyway, we'll get to more interesting things where we'll probably have to store the track priority in the global namespace anyway, but for now, I'll make do with this. Just multiplying things here seems to work. Now, let's see how I implemented the strength. Yeah, that's what I thought. There is this nonlinear equation here. Nice. Let's get to it. Do I have a I think I have a reference for where I got this nonlinear equation from. No. It was a Stack Overflow answer. I have that. I have a note about this somewhere. But not in the code, it seems. Anyway, the point of this equation is that the gain, or I guess I'm calling it the attenuation now. It's a better name. So the attenuation will be a number between 0 and 1. It will be 0 if the track is very silent, so this number is 0. Perhaps there is no audio running through the track, so that number is 0. And that is the minimum, because RMS is always non-negative, so the minimum is 0. And the maximum is 1, because we are taking the minimum between 1 and whatever comes out of this. So attenuation is a number between 0 and 1. To implement strength, I put this number between 0 and 1 into a sigmoid, which is a nonlinear function. I actually remember how I got the nonlinear equation, this nonlinear equation. I didn't make this up, of course. And I was looking for sigmoid functions for animation. So in CSS, you can animate stuff by sort of giving a Bezier curve of the positions you would like an object to have over time. And I went looking for how to implement that Bezier. I ended up finding other ways of doing animations, and this was one of these. So this is an equation you can use if you want to implement the CSS transitions. I'm not saying to use CSS transitions. I mean, you are a browser developer and you would like to implement that. This is an equation you can use. And it's probably a pretty standard equation, perhaps even used for like distortion and whatnot. Now, I will run my attenuation through this nonlinear equation, but there is something interesting that happens in my older implementation of the Automixer that maybe I will need to figure out how to implement here as well. And that is, even when the strength was not 1, I still had a notion of normalizing the gains. In other words, the attenuations, or I guess the gain allocated to all the microphones, would still add up to 1. And to make that work, I would need to know the track gains of all tracks. See, sum of all track gains, and then you take this particular track gain and divide by the sum of all track gains. This is normalization. Can we get away with not normalizing? Perhaps we can. We got away with not knowing other tracks' priorities. We can get away without normalizing. We can just run this through the nonlinear equation. Perhaps that will work. Let's see. So I just take the attenuation, or I guess let's start by having a slider. So this is a global slider. It's like the RMS window length. So let's have a slider 2 and change this to slider 4. And this will be the strength. I'll take the same range from before. Well, a strength of 0 doesn't make sense. It's effectively bypassing the plugin. But perhaps you would like to have that off and on situation where you gradually bring the plugin in. And I guess the same is true of the priority. Perhaps you would like to be able to mute the track and then slowly bring it back up. Yeah, I don't know. I'll leave this range. And that's that. Then we come here and we take the attenuation. Let's get that nonlinear equation. I guess a to-do for me is to check if this nonlinear equation is still a good one. Or I guess I'll stop calling it the nonlinear equation, it's a sigmoid. So the track gain is what I'm now calling the attenuation. And strength is the same name, so this should work. Bam. There you go. And this number was a number between 0 and 1. I would very much like it to continue being a number between 0 and 1. So let's analyze this sigmoid. Also because I want to see the sigmoid again. So let's put this into a graphing calculator. Why? Well, let's have a variable for strength. How do I add a variable? Plus new equation, new point set, new group, new equation from template. I don't remember if adding a new equation is what I want. Reevaluate expression. No, not really. I don't remember how to use Grapher anymore. Let's go to Desmos. I think I remember how to use this. Let's see. Strength. Well, all. Oh no, each letter is a variable name. Oh, I hate this. I'm sure there is a way for me to have a variable name that is more than one letter. But for now, I just have this strength be a number between, what is it, 0 and 5. How do I make this a range? Come on. Add slider for S. There you go. And the minimum is 0. The maximum is 5. And the step is 0.01. There you go. We have a slider in Desmos. And the default is 1. Now we are talking. Then attenuation, which I'm going to call A, is a number between 0 and 1 in steps of 0, 0, 1. There you go. And then, oh, no, the attenuation is actually our x-axis. So never mind that. X to the power of strength divided by parentheses. X to the power of strength plus 1 minus x to the power of strength. Did I get it right? Attenuation is x, or I guess this attenuation is x, this attenuation is y. That's what we want to see. How the attenuation will change with this sigmoid. Let me review the formula. Seems good. So this is what it looks like when we have no strength set. I guess this range isn't too good. Let's zoom in. We are interested in this space between 0 and 1. So let's make this full screen. So when the strength is 1, this formula won't do anything. Which actually begs the question, should I be doing all of this, or should I be checking that the strength is 1 and just skip this line? Is a conditional slower than a bunch of exponentials and a division? Conditionals are expensive. I mean, what I'm saying is I could do something like strength like that. And this saves me from computing the formula when the strength is 1, which is most of the time. But then I'm doing a conditional. That's expensive. You have to do some speculative interpretation and blah, blah, blah. So I don't know. I think I'll just do it like this. Perhaps computing a conditional is even more expensive than these exponentials and whatnot. I think that conditionals are probably less expensive. But anyway. So this is what we have now. And when I increase the strength, then check this out. This is what happens. Now, interestingly enough, it's going between 0 and 1 naturally, even though I didn't specify anything, probably because the denominator blows up or something. I don't know. I don't care. But it seems like when it's 1, it's a line that goes beyond 0 and 1, and otherwise it seems to break. Oh, in some values it doesn't break. Huh, cool stuff. Anyway, whatever. We are interested in this range between 0 and 1. So when the strength increases, you are allocating more gain to the microphones that were already not quiet. So think of the linear version. You would be allocating this much gain to this microphone. Now, when you increase the strength, you are allocating this much gain, which is, it's a lot more gain. You are allocating even more gain to microphones that had more gain, and you are attenuating even more the microphones that were already attenuated. And you can also go the other way around if you want. And when you get to 0, you get a straight line. So no matter the attenuation that you computed, you are going to get no attenuation at all. Or I guess you're going to get an attenuation of half. So that's probably why I had that normalization thing, because I would like the strength of 0 to not change the gain of the microphones. Yeah, perhaps that's what this is about. But hey, I could just do that by offsetting this up. It's something. Come on, let's see. All right. Exponentials are very expensive. So if the conditional is likely, then a conditional could be efficient. By the way, you are using that twice, so storing that in a temporary variable would probably be more efficient. Good points. And thanks for sharing your wisdom. So let's do this right then. There you go. I would think that the compiler would be able to catch this. It's a relatively straightforward optimization where you detect common subexpressions and you extract them into variables. Have you checked this? I remember you teaching me that you can in JSFX come here to the little debugging window and you can see the amount of code that was produced. And that's a good indication of how optimizations go. So did you check this? Because I think that common subexpression is such a straightforward optimization that this may be unnecessary. I guess I'll have to test it now. I'll have to test it. Because I don't think I ever did this trick you taught me, but I never used it. So now I have to do it. I'll do it. And if you have done it, then I will see in the chat and we'll compare our results. So if I have x equals 1, or I won't do that with x because maybe another optimization will kick in where it will do computations that it can at compile time. Like if I have x equals to 1, it can substitute x wherever it occurs at compile time. So I'll do that with the samples instead. statistics. So this is that, and then we change this like so. And then we compare. I'm not sure I know what all these values represent, but... Ooh, I am drawing on top of the thing. Come on, get that out. Okay, so source, probably the number of operations, the number of opcodes that will be generated. Then this is a lower number, so that's probably good. And then all of these below, I don't think that matters at all. So these numbers are lower than these numbers. I think that lower numbers are better. Not quite, not always. I think that lower numbers just mean the program was shorter before, and that was kind of a trivial assessment. Yeah, this is a longer program. It will have to assign to variables and everything, but it says little about the speed. I guess to test the speed, I would have to do this in a loop. But what I'm really interested in is knowing if the optimization happened. I want to have some insight into what the compiler did, and that much I don't have. Well, I guess I have an answer. The answer is the compiler is not doing the common subexpression optimization because the programs that are generated are not the same. So at least that much I know. We are not running exactly the same program, which means that it probably pays off to have this little bit, though it doesn't read great. But anyway, it's probably worth it. Yeah, thanks for bringing this up. Okay, so we are in this weird situation where we could be attenuating even when the strength is supposed to be 0, which is not good. And of course, there is the notion of normalization that we can apply, like in the previous implementation of the effect, or I can offset this whole curve so that attenuation doesn't happen if the strength is 0. But I don't know, let's just see what comes out of this. Oh, and I think I would like the strength to be a global parameter. So I want that to sync. Let's implement that syncing real quick. And I know that we are syncing this parameter, so let's just piggyback on that. I'm starting to notice a pattern arise. Perhaps in the library, we should have auxiliary functions for this notion. Oh, not for this though. But an auxiliary function for this notion of updating global variables that are synced this way. I'm not 100% sure it's worth having, because there may be other things you would like to do when you are changing. Like we set the length of the RMS window, but still, this pattern seems to be occurring often. Okay. The slider now should be global. And it is. And the strength is not affecting much. If the strength is 1, we are bypassing that block of code. And when I increase the strength, it is... Oh, okay, I see. I was speaking softly, so I was seeing this bouncing up and down too little for my taste, but it is now jumpy, right? That's the whole point. It is jumpy. If you look at the equation, when we have a high strength, it is super jumpy. Either your microphone is on or it's off. It's almost a gauge. And that's what we see here. We see when I'm speaking softly, we are in this region. So this microphone is barely attenuated, or I guess this sine wave is barely attenuated. But when I speak more loudly, we get into this region and then it's very attenuated very fast. Yeah, that's how you implement strength. And if I lower the strength, then I am attenuating all the tracks, but it's not bouncing up and down anymore. And now it is bouncing up and down again. So here the attenuation, we probably don't want that, but you can see that the bouncing is very gentle, while here it is more pronounced, and here it is even more pronounced. Yeah, there you go. I think we did it. That's one implementation. May not be the best one, but hey, I delivered the title of the stream. That doesn't always happen. So Tail has not tested, but now he has. And okay, and how do you test this? Do you just do this in a loop and they look at the CPU use? Because that's what I would do. But perhaps you have a smarter setup. And yes, doing this in 2 lines and extracting the common subexpression by hand is slightly faster. I'll take it. Our plugin is not doing much and it's already kind of CPU hungry. Let's see, the original Automixer, without doing anything, is taking 0.3% of the CPU. The new Automixer, without doing anything, is taking 0.1. And of course, now you have a bunch of instances of them. This is taking 0.2, 0.3. Interesting. Why is this version taking less CPU? Makes little sense to me. I mean, they're running exactly the same code, and the only difference is... Oh, hang on. Is my plugin taking 2%, 0.2, or is it the tone generator? No, it is my plugin. What the heck? Why are the 2 instances running exactly the same code, reporting different CPU use? That makes no sense. No sense. Is this because now there is no audio going through and denormalization is kicking in? I don't know. Let's stop my microphone. And then the CPU use goes up. Yeah, this is denormalization, all right. But why is the tone generator not making this go away? I don't know. It makes no sense. Has to do with denormalization, at least that much we know. This deserves an emoji. Where is the shrug? This is me. Makes no sense. I hadn't tested, but now, okay. You loop and look at the CPU use. That's what I would do. Aren't both versions doing RMS differently? Yeah, they are. The old version is not using the library, and this new one is using the library, so the RMS computation is very different. But never mind that. I'm talking about these two instances of the new implementation taking different amounts of CPU. I would really like my Automixer to be at 0.1 per instance. I'll take that. If you have 2 microphones, it's better than the old version. If you have 3 microphones, it's equivalent. And if you have 5 microphones, the old version is probably better. But I guess if you run more audio through this, more CPU will be used anyway. So it's on par with the previous implementation. It's fair. 0.1% CPU for this automixing is completely fair. But the normalization issue is not okay. And taking 0.3, 0.4% CPU per instance might be a tall order. I don't know. Anyway, delete and reload the plugin. See if the issue persists. It does. It does persist. And if I make this a triangle wave, if I make this a sawtooth, same. If I change the volume up and down, okay, I thought that perhaps I would be able to bring this number down by magic, by fiddling with parameters of the audio going into the Automixer, but it is not happening. So I don't know. That's a big mystery for me. One that I will figure out in a future session, because this one is about to end. So tomorrow we'll be back here and we'll be looking at perhaps the video stuff. Yeah, that is weird. It is weird, isn't it? Yeah, perhaps we'll be looking at the video part of things, which is interesting because you have to find what instance is the loudest. Perhaps we'll do something else entirely, but it will be about the Automixer. So I see you back here tomorrow, and thank you Tail and Bo and Benjamin for joining me on this session. I hope to see you again here tomorrow. Thank you to everyone else who is watching this either now or in the future. Have a good one. I see you back here tomorrow. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.